Alright guys, in this video we're going to do a host of problems. We're going to be doing questions 26 to 30. So that's 5 questions. And for 26, 27, 28, 29, and 30, we're going to be using the fundamental counting principle. Number 26 says, at a lumber company that sold shelves, a customer could choose from 5 types of wood, 4 widths, and 3 lengths. Find how many different shelves could be ordered. And I'm going to do these sections on the whiteboard. So, we have a type of wood. Okay, what's going on with my pen? Type of wood. We had width. And then we have length. It says here we have 5 types of wood. We had 4 widths for the wood. And we have 3 different lengths for the wood. To find out how many types of shelves can be ordered, we multiply the categories, the procedures for each section. 5 times 4 times 3. 5 times 4 times 3 is 100. Sorry, not 120. It is 60. 5 times 4 is 20. 20 times 3 is 60. There's going to be 60 types. Or 60 possible shelves. All right. Now, we're going to move on to number 27. Number 27 says here, and I'm going to scoot that over a little bit to get a better look. A person can order a new car with a choice of 6 possible colors, with or without air conditioning, with or without head seats, with or without anti-lock brakes, with or without power windows. This is annoying. With or without CD player. And how many different ways can a new car be ordered in the terms of these options? Okay. So for number 27, we have colors. Then we have air conditioner, which I'm going to call AC. We have heated seats, which I'm going to call HS for heated seats. We have anti-lock brakes. So I'm going to put anti for anti-lock brakes. I'll put anti-lock. We have power windows. Whatever that is. And we have CD player. Let me double check everything to make sure that I'm good. Possible colors, air conditioning, heated seat, anti-lock brakes, power windows, and CD player. I know what power windows are now. It's where you can use the switch to go up or down. There are 6 possible colors. When it comes to the air conditioner option, you have 2 options, with AC or without AC. When it comes to the heated seats, with a heated seat, without heated seats. When it comes to the anti-lock brakes, you can have it with or without. So that's 2 options. When it comes to the power windows, you can have power windows or have the old school windows we have to roll up with your hands by rotating it. And when it comes to a CD player, there are 2 options for that as well. Having it with a CD player or without a CD player. And to find out how many different ways a new car can be ordered in terms of the conditions above, you multiply the numbers together. When it says with or without, there are 2 options for that, and there are 6 colors. 1, 2, 3, 4, 5. When you multiply that, that's going to be 6 times 2 to the 5th power. And if you do that in your calculator, that's going to be 192 different ways. And that is it to question number 27. I learned something new about my tablet. Number 28. It says license plates are made using 3 letters followed by 3 digits. How many license plates can be made if repetition of letters and digits are allowed? Well, is allowed. So 3 letters. Letter 1, letter 2, letter 3. Followed by 3 digits. Digit 1, digit 2, and then digit number 3. In the American alphabet, we have 26 letters. And for our single digits, we have 10. Numbers 0 through 9. 3 letters followed by 3 digits. How many possible license plates? So, for my first letter, there are 26 possible options that can go there. Because I can repeat my letters after that, that means for my second letter, there are 26 possible letters that can assume that position. And there are 26 possible letters that can assume the third position. When it comes to my digits, there are 10 single digits that can take the spot for the first digit. If I use a digit, I can then repeat that digit or use the 9 remaining digits, which means there are 10 options for the second digit. And there are 10 options also that can be used for my third digit. So to find the number of possible license plates that can be made, we're going to multiply the numbers together. 26 times 26 times 26 with 10 times 10 times 10. That's going to be 26 to the 3rd power times 10 to the 3rd power if you're, using algebra. But I'm just going to multiply that. 26 times 26 times 26, then times 10 times 10 times 10. And that equals to 17,576,000 different license plates. All right, guys. That is the number 29. I hope that made sense. Hope you enjoyed that question. I keep saying hope you enjoyed it. Hope you understood the question, I should say. Number 28. Now we're going to move on to 29 and 30. And yes, I know this is a long video, but I like to keep the same topics together as in one video. Number 29 says here, how many 4-digit codes can be formed using digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9? So that is 10 digits. 10 single digits, which refers to right here. Erase that, it's going to be an extra. If the last digit cannot be 0, 1, or 2, and repetition of digits is allowed. Okay, let's scroll down a little bit. Number 29. we're looking to form 4-digit codes. So digit 1, digit 2, digit 3, digit 4. Now, if you notice, there is a restriction on the 4th digit because it says the last digit cannot be 0, 1, or 2. So cannot be 0, 1, or 2. Let's keep that in mind when we come to it. There is no restrictions on the first 3 digits, and repetition is allowed. So that means I have 10 possibilities that can take the place of the first digit, 10 possibilities that can take the place of the second digit, and 10 possibilities that can take the place of the the third digit. Now, for my 4th digit, if I cannot use 0, 1, or 2, that means there are only 7 options for me to choose from for my 4th digit. So that is going to be the number 7. Because once again, we're excluding 0 from that option, we're excluding 1 from the option, and we're excluding 2 from the option in respect to the 4th digit. But still, I am using a fundamental counting principle, so I'm going to multiply. And that's going to equal to 7,000 codes. And that is the answer to question number 29. Number 30. It says, how many different four-letter radio station call letters can be made if the first letter must be K or W, repeats are allowed, but the call letters cannot end with an O? Okay. Number 30. We have several things going on. So it's going to be a 4-letter radio station. Letter 1, letter 2, letter 3, and letter 4. Now, it says here, the first letter, and I'm going to zoom in. The first letter must be a K or a W. K or W. And the last letter cannot end with O. And with O. Okay. If the first letter must be a K or a W, that means there are only 2 options that can go there. There is no restriction on the second and third letter, and it says repeats are allowed. So that means for my second letter, because there is 26 letters in the American alphabet, I have a possibility, to put 26 letters for the second option. I can pick from 26 possible contenders. And the same thing when it comes to my third option. There are 26 possibilities that can take the third option. When it comes to the fourth option, it cannot end with O. So it can be any letter in the American alphabet except for the letter O, which means 25 options will be viable for the fourth letter. And because we're using the fundamental counting principle, we're going to multiply. So that's going to be 2 times 26 times 26 times 25. And that is going to equal to 33,800. And I believe that's going to be possible radio stations. Possible call letters, I'm going to say. All right, guys, that is it to the fundamental counting principle. Ooh, 15-minute video, pretty long. But I answered 5 questions using the fundamental counting principle and 5 different scenarios. Once again, let's take a look on where we started with question number 26. And let's look how we progressed to number 27 and the difference in the wording. Number 28 and the 29 was more advanced. And number 30 took the cake. Hope that made sense, guys. I'll see you soon. Take care.